Hi guys, welcome to week 4 of Unit 9, Linear and Nonlinear Functions. So what we're going to do today, so we've already talked about rate of change, and we've already talked about identifying functions from graphs and identifying functions from equations. So this week we're going to talk about identifying functions from tables, okay? You will have an assessment. This homework assignment will be due Thursday night, and you will have an assessment that will open up Thursday, due on the following Sunday, okay? So we're going to break this down into little chunks so we don't get overwhelmed. So today all we're going to talk about is linear functions and absolute value functions. So just linear functions and absolute value functions. And then on Tuesday we'll talk about quadratics, and then on Wednesday exponential, and we'll be done with this unit. So when you look at a table, how can you identify if something is a linear function, okay? Well, all that's really important is x needs to be going up by a constant amount. If x is going up by a constant amount, then the following things are true. So what you need to do is, for linear function, the first difference is the same. So first difference is the same. So in order for a function to be linear, the first difference is going to be the same. You're like, what does the first difference mean? What the heck's going on? And when we talk about first difference, we're talking about the y values. Okay, so we're talking about first difference, you talk about the y value. So let's look at number 1 and see what I'm talking about. So my x values right here going up by a constant amount, so we're good. If they weren't, then we'd have some issues. So what I do is I find the difference between 3.5 and 4.75. Well, the difference here is positive 1.25. Okay? 3.5 plus 1.25 equals 4.75. Okay? And then what's the difference between 4.75 and 6? Well, it's plus 125. Because 4.75 plus 1.25 is 6. And 6 plus 1.25 is 7.25. And 7.25 plus 1.25 is 8.5. And 8.5 plus 1.25 is 9.75. And 9.75 plus 1.25 is 11. So this right here, and I'm going to rewrite this one here. It looks like I don't know what that looks like. Let's rewrite that. So plus 1.25. So this right here is your first difference. It's the first time you find the difference between the two. Okay? So in order for something to be linear, let's go back at the top. The first difference is the same. That means every single number here is the exact same, which they are. You're adding 1.25 every single time, so that means that this function here is linear. Okay? So in order to be linear, the first difference has to be the same. Okay? So on the homework you'll go through, you'll probably want to wait till Thursday to do most of it. Or you can kind of try and find the first difference on them. And if the first difference is the same, you know linear. If it's not, don't classify it yet. Wait till we see the other videos. Now let's look at absolute values, because we're also going to talk about absolute values. So absolute values also has to do with the first difference. So absolute value also has to do with the first difference. So the first difference is same number but opposite signs. And what that really means is going to be positive and negative, same number. So again, absolute value, first difference is the same, so we're going to do what we just did with linears, but they're going to be the opposite sign. So like on number 1, if that was absolute value, it would be 1.5, 1.5, then negative 1.5, negative 1.5. Same number, but opposite signs. So let's look at number 3. Okay? So number 3 here, Our x values are all going up by the same amount, so we're good, so we can look at the differences. So, from, there we go, from negative 2.5 to negative 3.5 is minus 1, right? Because negative 2.5 minus 1 is negative 3.5. Negative 3.5, this would be minus 1, and this would be plus 1, plus 1, plus 1, plus 1. So if we notice that, the first difference are all 1s, right? But if we look at the sign, we have some positive 1s and then some negative 1s, okay? So that's not linear because they're all not negative 1 and positive 1. So the first difference is right here. It's the first time we find the difference between the numbers, and it's positive and negative of same number. Okay? So this would be an example of absolute value. Okay? So those are the two we're going to talk about today, our absolute value equations and linears. Again, just remembering that linears, the first difference is going to be the same exact number. And absolute value, first difference is going to be the same, but they're going to be opposite sides. So linear function, that was like number 1, and absolute value function was like number 3. So again, what I suggest you do tonight in your homework is to go through all the tables and find the first difference of all the tables. And say, are any of them the same number? If yes, write linear. Are any of them the same number but opposite signs? If yes, write absolute value. If no for both those, leave those blank and come back and watch the video tomorrow, and it might be one of the following ones. Have a great day, guys. If you have any questions, log on to Zoom. Thanks for stopping by.